In today's tech tip, we'll discuss using an SPI port to perform C-BUS transactions. C-BUS and SPI both use 4 signals to exchange data. You must configure the processor's SPI port for proper S-clock polarity, phase, speed, and master-slave settings. C-BUS signals are valid on the rising edge of S-clock. A single-byte C-BUS write begins when the C-BUS master asserts slave select and loads the slave device's C-BUS register address into the master SPI data register. The first SPI data interrupt means the slave device C-BUS address has been transmitted. At this point, the register data for the slave device is loaded into the master SPI data register. The next SPI data interrupt indicates the transaction is complete and slave select can be deasserted. Please note that slave select must be asserted for the duration of the C-BUS transaction. A single-byte read operation also starts when the master device asserts slave select and loads the slave device C-BUS register address into the master SPI data register. The first SPI data interrupt indicates that the slave device register address has been transmitted. However, the received data in the master SPI data register is garbage. Load a dummy byte into the master SPI data register to allow the slave C-BUS data to be clocked into the master SPI port. The second SPI data interrupt indicates valid data is available. After the data is read out, deassert slave select. This concludes our video. Please contact CML if you have any questions about the topics discussed in today's video.